In this tutorial, I'm going to talk about chi-square, test for independence, also known as a two-way. I'm going to look at academic performance and self-esteem. My null hypothesis is self-esteem has no impact on academic performance. My alpha is going to be 0.05, which means I want to be 95% confidence. And I'm going to test this against a chi-square distribution, and the distribution looks something like that, more or less. And I'm going to look at chi-square and critical values of chi-square. I'm going to set up a rejection region, which is the red area here. And again, I'll come up with some critical values from tables in the back of your stats book, and I'll show you how to do that as well. Took these numbers from some journal article I was reading, and I'm going to look at how to calculate chi-square. The very first thing I would recommend doing is making two tables. Slide the header over, and also the low. Now I have two tables. The one on the left is high academic performance and self-esteem, and the one on the right is low academic performance and self-esteem. This is going to make the calculations much easier. Then I'm going to look at what would be my expected values. The way I get my expected self-esteem is I look at the general population for high, medium, and low, and it turns out about 20% of the population's high self-esteem, 50% medium, and 30% low self-esteem. Now I need to know my sample size. I take 21 plus 31 plus 8, and this is my high academic performance, and my sample size for that is 60. So again, if I add up that row, it equals 60. So I add in a row called expected. So it's going to change that high to observed. So I have observed and expected. 20% of 60 is 12. And I'll put that there. Medium self-esteem, 50% of the population, so I take 60 times 0.5, which is 30, and I put that in the medium column. Then low self-esteem is 60 times 30%, or 18. And this entire row is equal to 60. 12 plus 30 plus 18 is equal to 60. As you can see, I have my observed and my expected values as well. I'll do the same thing for low academic performance. I take 12 plus 43 plus 35, which is equal to 90, and that's my sample size for low academic performance. I'm going to change the labeling of my table just a tad, not to confuse you. I'm going to change that low to observe and add in a row called expected. 20% of 90, or 20 times 0.20, is equal to 18, and that's my first expected value for high self-esteem. The next is 50% of 90, or 90 times 0.5, which is 45. Then finally 90 times 0.3, which is 27. Now if I add 18 plus 45 plus 27 is equal to 90. That's my sample size. And again, now I have a row of observed and what I expect. There. Now I have two tables for academic performance, low and high. And on the left-hand side, it's high. So on the left-hand side, I have high academic performance, and that sample size was 60. On the right-hand side, I have low academic performance, and that sample size is 90. Now for total sample size, I take 60 plus 90, which is equal to 150. and I will say n is equal to 150, and that's my sample size. So now I'm going to add a row for difference, and I'm going to take observed minus expected. I take 21 minus 12, which is 9. 31 minus 30, which is 1. 8 minus 18, which is negative 10. I'm going to do the same thing for the low academic performance, observed minus expected. I take 12 minus 18, which is negative 6. 43 minus 45, which is negative 2. 35 minus 27, which is 8. Now I take these differences and I'm going to square them all. So I take 9 and I square it, which is 81. I take 1 squared, which is 1. 10 squared, which is 100. Negative 6 squared, which is 36, last time I checked. Negative 2 squared, which is 4. And 8 squared is 64. Now I take the differences squared divided by the expected value. I get 81 divided by 12, which is 6.75. 1 divided by 30, which is 0.03. 100 divided by 18, which is 5.56. Then I take 36 divided by 18, which is 2. 45 divided by 4, which is 0.09. 64 divided by 27, which is 2.37. That's my last value there. Now I sum up all these values, and that gives me a chi-square of 16.8. And that's my chi-square value. So chi-square is equal to this little symbol, that's chi-square, and that's equal to 16.8. Now in your textbook, and your professor use a formula like this, they take the observed, which is the O, minus the expected, right there. And they get a difference. And that brown line, here's the difference, and that's equivalent to this right here. There. Then I'll take the difference, and I squared it, which is that black line right here. And that's equivalent to that right there. I took the difference squared divided by the expected, which is all that light green or that lime green there. And that's equivalent to that. And then I summed everything up. And that's sigma, which is sum. Now I'm ready to move on. And I am now going to calculate the degrees of freedom. So I look at the number of categories, and in this case I have 3 categories, 1, 2, and 3. And I also need to know the number of rows. In this case I have 2 rows. So I take R for rows minus 1 times C for categories minus 1. And that C is for categories, that's C right there. So degrees of freedom I'll abbreviate to DF, and this is equal to 2 rows minus 1 times 3 columns, or 3 categories minus 1. So this is 2 minus 1, which is of course 1, times 3 minus 1, which is 2, and 1 times 2 the last time I checked was 2. So degrees of freedom is equal to 2, and my chi-square is equal to 16.8. So now I bring back in my alpha of 0.05 for 95% confidence. Now I'll draw in my chi-square distribution. Looks something like this. Whoop, like that. And I look for a critical value in a table on the back of your book. I'm going to tell you how to do that in a second. Everything to the right of this critical value in that red area is my rejection region. The green area is not in the rejection region, obviously. Now there's this table in the back of all stats books, and it looks something like this. And degrees of freedom on the far left-hand side of that column. And across the top, you're going to have alpha values. And you'll have 0.10, 0.05, and that's what we're using, by the way, and then 0.01, maybe a lot more. And let me just put in the critical values. These are the critical values. Take my degrees of freedom, and that tells me what row I'm on right there. And it intersects with the alpha value of choice, which is 0.05. So my critical value is 5.99. So obviously 16.8 is much larger than 5.99, and so I can conclude by my initial hypothesis, self-esteem has no impact on academic performance. I reject that notion. I don't necessarily conclude that it does, I just reject this null hypothesis. I want to tell you one more thing. In the literature, it's written a little differently. I want to show you how it's written. So it has chi-square and a parenthesis, and then it will have degrees of freedom, comma, sample size, which is 150, we calculated that before, is equal to the chi-square value of 16.8, comma, p less than 0.05. In journal articles, you'll see it written as this, which, again, review, the first value is chi-square, degrees of freedom is 2, the sample size is 150, this is all equal to the chi-square value of 16.8, and then I have my p-value right there, and there you go.